So the unit is broken down into 2 lessons. So you'll see here that we have some review of exponent laws, and then some more exponent laws. Then we're going to talk about exponential and logarithmic functions. I'm not going to emphasize the graphing aspect. So there's a few examples in here that discuss graphing, but I'm going to leave those for you to look over on your own. So I'm not going to do any graphing with you today in class. And then we're going to talk about logarithms, and that takes us to where I want to get. So basically, we want to get to question 69. And then after that, there's more continuation. You'll see that we talk about applications of logarithms and solving exponential and logarithmic equations. So this application stuff we're going to do next time. So that's why I say today's class is extremely mechanical. Lots of writing, but writing in short bursts. No marathon questions. Maybe a couple questions that are longer, but we're doing 69 questions today, but you don't get too rattled because they're not extremely long questions. And if you don't believe me, we're going to probably hammer out the first 10 questions in the first, I don't know, 3 minutes, 4 minutes. If you don't believe me, check it out. So remember, this chapter we're talking about exponent laws, exponential functions, and then later something called logarithms. So in order to talk about exponential functions, we need to review our exponent laws. So in the chat, you're more than welcome to throw out some numbers at me. What's 5 squared? No problem. Now, if my stylus starts to fail me, I might have to type it. Thank you, Irvin. So if my stylus gets a little slow, that might slow down the conversation. What's 2 to the 5? 32. Try not to use a calculator, not you, Irvin, and specifically, I mean, but if anybody, try to do these in your head if you can. Maybe 2 to the 10 you don't know in your head, but 2 to the 10, if you play that game on your phone, 2048, then 2 to the 10 is one of those tiles. It's the 10th iteration. So those are just positive exponents, and they are positive integers. Let's talk about negative and 0 exponents. Do you remember what a negative exponent does? What does a negative exponent do? Yeah, it's a flip, right? That's good job, Jai. So I said flip, but you could say a reciprocal. That's the appropriate formal. I might get lazy and say flip. It's less syllables. Anything to the power of 0, what do you get? What's anything to the power of 0? What's 11 to the 0? Silence. Oh, yes. Thank you, Anthony. So, thank you, Vittorio. So, wait a second. Why am I asking the same question 3 times here? What's the answer to 6? Again, no calculator. Don't cheat. So, I mean, you're allowed to use a calculator in the course, but what's the answer here? Silence. Max is first in there. Thank you, Jordan. That's -1. You see this negative sign here? Thank you, Jason. See the negative sign here? The negative is not influenced by the 0. However, when you put it in brackets, it is. So when you have anything in brackets to the 0, then it becomes a 1. So now what we're going to do is talk about combination questions. So let's combine the negative exponent with an integer other than -1. So here we have -3. So this is actually 2 things. Let me say it again. I don't want to use the word reciprocal. It's too many syllables, if you don't mind. So I'm going to say here the negative means you flip it, and the 3 means you cube it. So this is the same thing as 1 over 4 cubed. There's my stylus starting to slow down. And 4 cubed is 64. So this is 1 over 64. So when you have a negative exponent, other than -1, you flip it, and then you apply that power. So that power is 3 here. You could also cube it first, and you'd get 64, and then you could flip it and get 1 over 64. So that applies to these ones as well. So this is going to be 1 over whatever that number is with a positive exponent. And 3 to the 3 is what? 3 times 3 times 3 is 27. Okay, now in this case, the negative sign is on the outside. So that negative sign is not influenced by the negative 1. So just put it on the outside, and then take the 4 to the negative 1 and flip it to get 1/4. I like to use the word spectator. Like think of when you go to a basketball game, like a Raptors game or whatever, and you're a spectator, right? You don't play basketball. You just sit there in the crowd and eat popcorn. So this guy over here, this negative sign here, that's a spectator. It doesn't participate in the operation. In the next question, though, the negative belongs to the 4, and it's in brackets. So now it's not a spectator. It's not passive. It's part of this process. So we're going to do 1 over whatever is in the bracket. So 1 over that. So actually, you get the same answer. One comment here is you should always make the denominator positive. So take that negative sign and pull it out of the fraction. So that's question 11. See? That took us about 6 minutes, a little bit longer than I expected, but that's okay. It is the first lesson of the week, and it's 9 in the morning. Anyway, I hope you had a good break. So what's up with this question here? We got pi. Now, I don't want you to pick up your calculator, at least for the first, probably the first 40 questions or 30 questions. There might be a few that we need a calculator. But this question here, the issue that I have with it is that the exponent is negative. You should always make your answer with positive exponents. I will not tell you that on a test. I will not tell you to make the answer have positive exponents. I expect you to do that yourself. And I know that if you've taken any math courses, recently at least, if you've forgotten this over the years, you haven't been in school for a while, I respect that. What's the problem with number 11, Jai? Tell me what's wrong. Example 7 is brackets to the 0. Okay, example 7 is different because the 0 turns everything in the brackets to a 1. In example 11, when you have a negative 1 applied to any quantity, you do 1 over that. So if you have something to the negative 1, I don't care what's in that box. It's 1 over that box. You understand? You're welcome. Yeah, I don't care what the number's in there. For all I care, it could have your name in there. I respect your name, but I'm just saying it could have your name in there. It could be 1 over John. I don't care. Like it's 1 over whatever's in those brackets. Okay, this next question now we're just playing games. Now we're just doing calculations with BEDMAS. So hopefully you remember BEDMAS or BODMAS or PEDMAS or whatever the heck you might have called it back in the day. Having issues with the stylus, if you don't mind. So here we take the brackets inside first. We get negative 2. And then you square it. And then negative 2 times negative 2 is 4. So anyway, the next question here, the next few questions are just ramping up this BEDMAS calculation stuff. So like question 14, think of it as a skill testing question. I remember when I was a kid, if I won a prize, like if I opened a bag of chips and there was a prize in it or something, or back then it would be like you had to answer some type of a skill testing question. So I remember seeing something like this, and it'd be like, oh, you have to get this right. But I was like, 8 years old, and I'm like, I don't know exponents. I'm 8 years old. But anyway, I guess to win the prize, you got to figure it out. So for this one here, let's go through it a little bit slow here. I'm going to just do all of this, and I know that you can do most of that in your head as well. This is 3 times 4, which is 12. And then 2 to the 3 is 8. I think you're way ahead of me there. And yeah, that's definitely 1 over 16 because you got 4 to the negative 2. So this is 1 over 4 squared. This is very painful for me to do, guys. Sorry. It's just this thing is so slow writing with it. 1 over 16. Okay, here's another one. This one here looks like it's a bit of a chore, so I might start typing these depending on how things go. So for this question, we have a fraction. So 2 to the 3 is 8, 3 to the 2 is 9, 4 to the 0 is 1, and 2 to the negative 1 is half. Now you could go through this and work with your fraction. So 1 plus a half is 3 halves. That's going to be 17 divided by 3 halves. Which you can invert and multiply. And get 34 over 3. There's a little bit of old school math. Hopefully you remember some of that. So all of those calculations we did up to this point, remember I said 69 questions, and look at that, we almost finished a quarter of them already. Not a quarter yet, but almost a quarter. And we're not even into 15 minutes in the lesson. Anyway, we're not under the clock here. I'm not a cab. I'm not going to charge you extra. Anyway, let's talk about the exponent laws here. Do you remember how to process these types of things, like x to the 3 times x to the 4? What do you do to the exponents? Yes, you add them. Thank you. So that'd be x to the 7. Good. And what would you do for this one here? What do you do to the exponents here? Multiply. Thank you, Anthony. Perfect. So I expect you to be familiar with these. And if you're not, you're maybe a little rusty. There's tons of these questions in the textbook. I don't remember specifically which questions I assigned, but if you go to the section in the textbook, you can hammer out a dozen of each of these. So that'll get you back up to speed. Now we can combine the rules into questions like number 18. So when you see a question like this becomes 2 to the 4, x to the 8, y to the 12. So this question is very similar to example 17. The idea is that you're taking the 4 and you're multiplying it in. So 4 times 3, 4 times 2, that's how you get these guys, the 8 and the 12. But then the 4 here might not be obvious to you, so let me clarify what happened there. The 2 here actually has a 1. It's 2 to the 1. So you're doing 4 times 1. So that's how you get 2 to the 4 here. And then nothing to do with the variables, but the coefficient, you could expand that out as 2 times 2 times 2 times 2, or 16. So there's the answer to question 18. How are you with the pace? Is the pace okay, everybody? Feel good about the pace? It's a very, very quiet crowd today. How is the pace, people? Can you explain that one more time? Yes. So this question here, thank you, Jason. This question here, so who's asking? Matthew. You see, do you understand how we multiply the 4 and the 3 to get 12? Thank you, Vittoria. Okay. Well, that's what you're doing here. That's what you're doing here, Matthew. You're multiplying the 4 by all of the exponents in the bracket. These quantities are multiplied, so that means that it's a power to a power. So 4 times 3 is 12, 4 times 2 is 8. The one thing that might be confusing is the 2 to the 4. But it's understood that you have 2 to the 1. It's understood that the 2 has a power of 1. So you're multiplying a 1 times the 4 to get 2 to the 4. Is that better? Matthew? Cool. Thank you, sir. Okay, question 19 is a hilarious question because I've asked this in class and as a joke, but not to like be mean or anything. Yeah, as a joke, I asked the class. Okay, I gave them. Honestly, I'm not trying to like rattle anybody. I go, here, you got 5 minutes, and then they think that they have to write down like, 500 lines of an answer. But this answer is only one line. This is the answer. Jai, your answer is also good too. I'm not saying anything about your answer. Your answer is just fine. But this answer is good enough. That's all I care about. The only issue with this question is that the 2 exponent is negative. I don't care about the fact that that it's 1 over something squared. You can expand it. So what Jai has written in the chat is perfect, but you don't have to do that for me, because when you're talking about fractions with variables, the benefit of expanding the denominator is not very it's not very common that you expand the denominator to do something with it. I know from my experience that there are occasions where you should expand the denominator, but it doesn't really need to be expanded. So let's go to question 20. 20 is reminiscent of something that we did in the quadratics chapter. So the issue here, always going back to what I'm most interested in. Where did you get the 1 over from? Because it's a negative exponent. A negative exponent. See, it's to the negative 2. So I flipped it and I made it positive. So over here, the issue is that the exponents are positive. So see, 1 over a plus 1 over b. However, notice that the question says express as a single fraction. So I need to combine them into one fraction. What's the lowest common denominator? What's the lowest common denominator here? Thank you, Matthew. So that means that the first one I need to multiply by b, and the second one I need to multiply by a, which gives us the desired result. So that's a plus b over ab. That's the answer right there. Pretty cool. Nothing too dangerous. This question, thank you, Shaquille. This question here is actually very similar to a question we did prior to the midterm. So actually what we can do is we can recycle the previous question. So I'll say here, using example 20, we can say that we have 1 over z equals 1 over x plus 1 over y. And then you have 1 over z, and then we'll use the pattern that I used on the previous question, which was x plus y over xy. And then to get z, you just take the reciprocal, or flip, if you like, both sides. This question is like, do you remember the question about Bob and Mary painting houses together? If you remember that question about painting houses, that's exactly the process that we did for that question. Most surely now completed a third of the questions, almost. So I think we're doing all right. So I see the class is we're at 28 people in the chat. I think the class is around the low 30s, like around 32, I think. So This is if we were in the classroom together, this is where I tell people, you know, when you're in class and someone just shows up late and they're kind of like frantic and they're like, "Oops, I'm sorry, I'm late" or whatever, and they sit down. I'm sure that's happened to you back in the day in like regular, normal situation in school. Well, that happens often during the semester if we were in a classroom, physical classroom. So a student might show up late and say, you know, am I okay? Am I like, what did I miss or whatever? And usually what I'll do is I'll just point to the board, as not mean or anything, just joking, obviously. And I'll say, hey, can you do this question here? This guy right here, 4 to the half. And if the student gets it correct without a calculator on the spot, I'm like, yeah, you're fine. Have a seat. Because it's true. If you can do this type of question, I'd put money that you understand how to do all the other questions that we covered. This type of question though is different. Can you describe to me in the chat maybe what's different about this type of exponent question compared to the other ones? What's interesting about this exponent now? What's changed? What's weird about it? Anybody in the chat? Yeah, it's a thank you, Cole. Perfect. It's a fraction. Yes, it is, right? So do you remember how to deal with an exponent when it is a fraction? So somewhere in grade 11, this is grade 11. So it turns out that when you have 1 over a number, that the fraction represents the following. I'll show you in less than 10 seconds, Cole, and everybody else as well. It means square root. So when you have a 1 over, the denominator of the fraction is the order, if you like to say the order, of the square root, of the root here. So in this case, it's a second order root, or just a square root. So what's the square root of 4? That's easy, hopefully. That's a 2. I was very pleased with your midterm for your solving equations ability. So in general, the class did really well on that. So do you remember a little bit more about that now? For those that weren't kind of sure about what the fraction exponent does, is that better now? Do you remember that now? Is it coming back to you? Awesome. Thank you, Cole. What did you do to the 2? So are you talking about from here? You're welcome. Yeah, so basically, whatever the number here is the root. So it could be a 2 root or a 3. So Jordan's question, how did I lose the 2 from here to here? Is that your question? Okay. Well, when you have a 2 root, it's customary that you don't have to write it at all. But if it wasn't a second root, then you have to write it. So I'll clear for you, Jordan. The next example will answer your question precisely. So for this question, it's the 5th root of 32, and there is no shorthand. So as far as you're concerned, and this goes for everybody, you don't have to write the thing in red. The thing in red is just it's a lazy shortcut for not writing the 2 because square roots happen all the time. Of all the roots that we use in our life with mathematics, the square root, I'm pretty sure, is the one that pops up the most. So now, do you know the 5th root of 32? Maybe not. But of course, you do have a calculator, and you can definitely exercise your calculator skills here. However, when you do have a 5th root of something, what you're really asking yourself is what? That's a question mark there. The 5 equals 32. That's the question that the 5th root is answering this question. Let me put a box here because the question mark looks weird. So what number to the power of 5 would be 32? Now, I told you that the first questions in this booklet are all going to be pretty much no calculator. So you can just guess. It's actually 2. 2, 2, 2, 2, 2. I counted 5 of them, I think. That's 32. So that's what you do when you run over. These questions build like a house. So can someone tell the class what's different about 24 compared to 23? How is 24 different? What's different about 24? The negative. Thank you, Vittorio. So do you remember what we did earlier? A negative exponent means you flip it. That's a 1 over question. And then the 3 means a cube root. So you do baby steps, guys. I don't care if it sounds kind of childish. You do baby steps here. That's how I do it. I'm not trying to be cool. I do baby steps. I flip the expression here, so it's 1 over, and I make the exponent positive because now I flipped it already. And then I convert the 1/3 into a third root. So it's a cube root. And then think of a number times itself, which is 8. I mentioned that the numbers are very nice for the first batch of questions, or you can just grab your calculator and do that. If you don't know how to do this on your calculator, there's a button or a feature for it, and you might have to just YouTube it and say, how do I do cube root on Casio or whatever calculator you have. Alternatively, though, you could just type the question on your calculator if you're familiar with using the exponent and the brackets well. So anyway, that's 24, and we're gonna do about 5 more of these questions, and they just build up more and more. So 25 here. So the way that I like to say this is that this question has this exponent is negative a quarter, and that means that there are 2 operations. There's the flip or reciprocal, and then there's the fourth root. So this is 1 over 81 to the quarter, which you can then write as 1 over the fourth root of 81. Anybody know what the fourth root of 81 is? 3. Thank you, Jai. So that's 1/3. And question 26 is the same thing. So I can just kind of, cut and paste this question and replace the 125 here. And instead of a third root, a fourth root, sorry, it's a third root. So what's the cube root of 125? 5. Thank you, Jai. So if you're wondering, is there a single question, one question that I could ask that encompasses everything that I've talked about in terms of exponents up to this point? It's this one. 27 is kind of like the big question. If you understand how to do 27, then I am so confident that you can piece together everything else. So 27, let's go through it. I want to mention here that this exponent here has 3 important numbers, or 3 important features. It has the negative. You know what the negative does? Why is it 5? Because the cube root of 125 is 5. Because 5 times 5 times 5 is 125. So in this question here, there's 3 features. There's the negative. The negative means flip. And then there is the 2/3. So let's talk about this 125 to the 2/3 a little bit more detail. So the 3 is a cube root. So the 3 here is a cube root. And then the 2 comes later. That's how you process an exponent that has a numerator other than 1. When the numerator is not 1, you just put brackets on the root and then you put that power. You can answer this question 6 different ways, but this for me is the most safe way to answer it. So at this point, we can recycle the previous question because we know what the cube root of 125 is. It's 5. And then we can square that answer. So there you go. That is that's the answer to question 27. Now 28 is a bit of a monster. So I'm going to screenshot it from my answer key. Hopefully it turns out well. I'll just put it right here. So let's take a look at this. It's actually, honestly, it's the same as the previous question in terms of style. The only difference is this negative sign. That negative sign, you see how it just carries through the answer? As far as I'm concerned, just ignore the negative sign there for a second. I'm just going to cross it out. So what you have is 8192 to the negative 3/13. So the negative means flip. That's why it's 1 over here. The 13 is the root, and the 3 is the power. So it's all about organizing the three numbers and how they affect the number, the base, 8192. The 13th root of 8,192, you can check it on a calculator. It's going to be 2. So that's how you get a 2 here. And then you can finish off by 2 to the 3 to get 8. Now, what about this negative sign in the front? Well, as I mentioned earlier, it's not in brackets here. Sorry, it's not in brackets like that. So I don't care about the negative sign. The negative sign, as far as we're concerned, is a spectator. So it just carries through the answer until the very end. And that, how did I get 2? Right here, Shaq? It's the 13th root of that. You can check that on a calculator because 2 to the 13 is 8192. It's not common knowledge that 2 to the 13 is 8192, but you can check it on a calculator. If you've played 2048 as much as I have, then you can do that. I'll get my phone and I'll show you my 2048 score, Joseph. Okay, just take a look at 29 for a second. I'll go grab. You guys can have a laugh. I started playing this 2040 since December last year. It's saved. I still haven't lost from December last year. Can you see it? It's the 500,000 tile. It's the 500,000 tile. But I'm playing the mega screen. This is honestly, this one's easy. It's the mega screen. You see the mega screen? This game has been going on since December. I'm trying to see how far I get in a year. Yeah, no, 4x4 I can do. 4x4, my best is my best on 4x4 is 8192. I can get the 8,000 tile. If you can get the 8,000 tile on that, then you're laughing. Like then you're pretty solid. Anyway, I'm sure some people have already started 29. I'm just give me a moment, people. I'm just gonna look at something here. Okay, so I'd like to do question 29 to 32, and then we'll take a break. So 29 here is just a mechanical a mechanical barrage of questions. Let's see how we do with it. I'm going to actually just cut and paste my answer for this one. I might do these for these more annoying questions, if you don't mind. And by the way, these answers will all be put on Blackboard at the end of class today, so I promise to do that right after we finish our lesson today. Anyway, let's take a look here. I know that I've written it down, and I can discuss it with you. Whoops. So just take a look at the first step. I'm trying to just hide everything else. Anyway, 5 squared is 25. 9 to the half. What the heck happened there? 9 to the half. Why is that equal to 3? Why is 9 to the half equal to 3? Because 9 to the half is the square root of 9. And same thing with 4 to the half. 4 to the half is 2 because 4 to the half is the square root of 4. And then you have some other stuff on the bottom here. Negative 5 to the 0. So negative 5 to the 0, remember anything to the power of 0 is 1. But there's a negative sign that is not influenced by the 0. So there's a minus sign right there. The 7 is easy. There's nothing there. You just copy the 7. No problem. So this is the one that might confuse some people, is this one here. Is 4 to the negative 3 halves is equal to 1/8. So let's go through that one here. 4 to the negative 3 halves is 1 over 4 to the 3 halves, which is 1 over the square root of 4, and then you cube it. So that's 1 over 2, because the square root of 4 is 2, and then you cube it. So that's 1 over 8. So that's how you get the 1 over 8 there. Once you get to this step, though, once you're in this step, then everything should be better for you, because now it's just fractions. So the rest of the question, I'm going to leave it for you to look over on your own. It's just manipulating fractions. And I did a previous question where I just simplified some fractions, so hopefully that helped you dust off some of the cobwebs of what you might have forgotten. And we can move on to the next question. If you want to practice more of these, I have recommended similar questions in the textbook. And actually, this question I think I took from the textbook, and I might have changed a couple of numbers, just so that you have variety. Okay, number 30. Number 30 is looking pretty dangerous, but maybe we can get somewhere reasonable with it. So let's see what we can do with this. I'll go through this one very carefully with you. The first thing I want you to do is ignore the 2/3. This exponent of 2/3 is the last thing that you're going to do in this question. So I'm just going to paste it a bunch of times. And then I'll deal with the stuff on the inside. So here we have this. Can someone tell me what's x on the denominator? What goes here in the bottom? Do you add them or do you multiply them, man? Yeah, it's a 5, right? Okay. Now the numerator is a fraction. That fraction, is it 3 over 10 or is it 10 over 3? Which way does it go? It's a fraction. Which one is it? 3 over 10 or 10 over 3? Thank you, Irvin. Now, what do you do to the 10, this guy here? What do you do to these exponents? You add, subtract, multiply, or divide the exponents. Do you remember what you do there? Do you add them, subtract them, multiply them? Yes, thank you, Jai. Well, look here, right? You added them before when they're multiplying common base. Here you subtract. So you get that. 10 over 3 minus 5. I leave that for your fraction skills. That's negative 5 over 3, I'm pretty sure. We're almost done the question. So what do you do with these exponents here now? The negative 5 over 3, positive 2 over 3. Do you add? Yes, you multiply. Thank you. So negative 5 over 3 times 2 over 3. That equals x to the... I'll answer that question in a second, Lucas. Lucas, is your question here? Why is this negative here? It's 10 thirds minus 5. It's 10 thirds minus 5. Is that better, Lucas? You're welcome. Okay, so we're almost done now. The only thing that's bugging me now is that the exponent is negative, so we should make the exponent positive. And how do we make the exponent positive? Good job. You're using my lingo. Good job. That's the answer. I don't care if you write the answer as a root or if you leave it as 10 ninths. It doesn't really matter. That is not a big deal. So let's go to question 31. I might assign 32 as just homework for, but we'll do 31 together right now. And then we'll take a break. So it says derive a formula for the surface area of a cube in terms of its volume. So what the heck's going on there? Let's talk about cubes. Here's a cube. Don't mind the choppy drawing here. I'm going to just call the length of the cube x, x, and x. They're all x. That's my picture. So I just decided to let x be that, okay? So here, let's write some words. Let x be the edge length of the cube. What's the volume? What's the volume of the cube? In terms of x, can anybody tell me what the volume would be? Thank you very much. Good job. What's the surface area? A little trickier. Well, how many faces does a cube have? How many sides? 6. Thank you, Shaq. Well done. 6x squared. Sorry. Here we go. So the question is asking for the surface area in terms of the volume. So what we need to do somehow is get rid of the x. So what I'd like to do is somehow, maybe we'll do the following. We'll isolate x in the v equation and substitute into the a equation. That's my strategy there. Power of 3. Which one, Jordan? The area formula? It's going to be squared because it's an area. Area is always a squared. So let me ask you this question. What's the area of this? Just this face here. Can you tell me that area? Yeah, it's length times width, which in this case is x times x, because it's x times x here. It's x squared. And now, how many of those faces are all over the cube? How many of those things are there? How many sides? There's 6 of them. So that's why the surface area is 6, okay? So it's not cubed. But the volume is cubed because it's, like you mentioned, length times width, but then you times it by height. You're welcome. These are good questions. You weren't expecting probably to be given the geometry review the measurement review out of thin air here. Anyway, let's isolate for x in the volume equation. So we had v equals x cubed, which we can rewrite x equals v to the 1/3. Or if you want, you can use the cube root here. I'll use a cube root. Let me use the cube root. It's easier to talk. Like that. Remember, the opposite of a square is a square root, or the inverse. The inverse of cube is a cube root. So we can plug that in now. So a equals 6x squared, which equals 6 times something squared. And what something is that? Well, I can plug this in right here. And that's the answer. That's the answer. See you later. Honestly, very satisfying little question because it reviews your measurement material, but also it gives you a practical application for why you would want to know exponent laws with fraction exponents. You could also write this a different way if you like. This answer, the red answer, is perfect. But you could also write it like this if you want to be using just exponents. You could write this as v to the 2/3. There we go.